Many of the technologies we use every day exist because of ideas Nikola Tesla explored more than a century ago: electric motors, alternating current power systems, radio transmission, and wireless energy concepts were all part of Tesla's work. Because of this, people often ask an interesting question: can Tesla's ideas still work today, or were they only theoretical experiments from another era? The short answer is that many of Tesla's ideas not only work today, they already form part of the modern electrical world. But at the same time, some of the concepts often associated with Tesla are misunderstood or simplified in ways that create unrealistic expectations. To understand what still works, it helps to separate Tesla's real engineering contributions from the myths that developed around his name. During the late 19th and early 20th centuries, electrical engineering was still a developing field. Scientists and inventors were experimenting with different ways to generate, transmit, and control electrical energy. Tesla focused much of his work on how electricity could be transmitted efficiently over long distances. His most famous achievement was helping develop the alternating current power system. Before alternating current became widespread, many electrical systems used direct current. Direct current worked well for short distances, but it was difficult to transmit efficiently over large power networks. Tesla's work with alternating current generators, transformers, and motors made it possible to step voltage up and down using transformers. This allowed electricity to travel long distances through power lines and then be safely reduced for use in homes and businesses. That principle still powers the modern electrical grid. In other words, one of Tesla's biggest ideas is already everywhere, but Tesla also explored other concepts that were more experimental. One example was wireless transmission of electrical energy. Tesla believed that it might be possible to transmit electrical power through the atmosphere using high-frequency electrical systems and large resonant structures. His most famous attempt at this idea was the Wardenclyffe Tower project. The goal of this structure was to explore the possibility of transmitting electrical signals and potentially power across long distances without traditional wires. While the project was never completed, the concept helped push forward research into radio transmission and wireless communication. Today, wireless technologies such as radio, television broadcasting, Wi-Fi networks, and satellite communication all rely on principles related to electromagnetic waves, the same physical phenomena Tesla studied. However, transmitting large amounts of electrical power wirelessly across long distances remains difficult and inefficient using current technology. This is one example of how an idea may be scientifically valid but still limited by practical engineering challenges. Another area where Tesla experimented was high-frequency electrical systems and resonant circuits. Tesla coils, for example, are devices that generate high-voltage electrical oscillations. These devices helped scientists explore how electrical energy behaves at different frequencies. Modern electronics, radio transmitters, and communication systems rely heavily on resonance and frequency control, ideas that were central to Tesla's experiments. In laboratories and educational environments, Tesla coils are still used today to demonstrate electrical resonance and electromagnetic effects, but again, it is important to understand the difference between demonstration and large-scale power technology. A laboratory experiment can prove a physical principle, but turning that principle into a practical energy system often requires solving many additional engineering challenges. Efficiency, safety, materials, cost, and infrastructure all influence whether a concept can become a real-world technology. Tesla himself understood this very well. Many of his projects involved years of testing and experimentation. Some ideas worked immediately and became widely adopted. Others remained experimental because they required tools and materials that did not yet exist. This brings us to an important point: technology often evolves in cycles. An idea that is difficult to implement in one century may become possible later when materials, electronics, and manufacturing methods improve. For example, modern power electronics, semiconductor devices, and advanced materials allow engineers to control electrical systems in ways that were impossible in Tesla's time. Because of this, some of Tesla's experimental concepts continue to inspire research today. Wireless charging systems for phones and electric vehicles are one example. These systems use electromagnetic fields to transfer energy between coils without direct electrical contact. While the scale is much smaller than Tesla originally imagined, the basic principle of energy transfer through electromagnetic coupling is similar. Resonant circuits and high-frequency electrical systems are also widely used in modern engineering, from radio transmitters to medical imaging equipment. Engineers rely on carefully designed electrical resonance to control how energy moves through circuits. In this sense, Tesla's influence remains very real. But perhaps the most important lesson from Tesla's work is not any single invention. It is the mindset behind the experiments. Tesla approached electrical engineering by asking how physical laws could be used in new ways. He studied how electric fields, magnetic fields, and resonant systems interacted with each other. That type of thinking still drives innovation today. Engineers continue to experiment with energy storage, wireless transmission, power electronics, and electromagnetic systems. Sometimes the results lead to new technologies. Other times they simply deepen our understanding of how electrical systems behave. Either outcome can move science forward. So when people ask whether Tesla's ideas still work today, the answer is both simple and complex. Many of his most important ideas already power the modern world. Others remain experimental concepts that continue to inspire engineers and researchers. But in every case, the real value lies in understanding the principles behind the ideas. Electricity follows the same physical laws today as it did 100 years ago. What changes is our ability to design systems that use those laws effectively, and the more clearly we understand those principles, the easier it becomes to explore new technologies. If you found this explanation useful, consider subscribing to the channel. New videos break down complex electrical concepts and experimental energy ideas into simple explanations that are easier to understand. And if you want to study how some of these electrical concepts are organized into practical systems, there is a useful resource linked in the description that outlines the main components and structure people often examine when learning about experimental energy setups and small generator designs.